is APAB. We are back with our third video of section 2.5, which is implicit differentiation. So, a quick reminder about notation. When we differentiate with respect to x, dy dx, we end up with d squared y dx squared, which you can kind of see because if you actually look at these letters in order, there's two d's, so d squared y, right? And on the bottom, both the d and the x have two, so it's like dx quantity squared, although we don't write it on the whole thing. We treat dx as one letter, basically. Cool. So let's go ahead and walk through E6. So we're going to find the second derivative of x squared plus y squared equals 16. So in order to do that, just like we've seen with differentiating before, we have to differentiate to the first derivative and then do it again for the second. So let's go ahead and find the first derivative, right? So we're going to get the derivative of x squared, which is 2x, plus, now when we differentiate y squared, we're going to have to use the chain rule because it's y, not x. So I'm going to get 2y, but then I just differentiated y with respect to x, right? And on the other side, I'm going to get a 0. Again, that's a pretty common mistake that people accidentally forget, and you know, you have a brain fart, you forget that that's supposed to be a 0. So now we're going to solve for dy dx, right? We're going to solve for this. So when we do that, we'll subtract the 2x over, so we'll get 2y dy dx equals negative 2x, and then we're going to divide by the 2y, and I would suggest that you cancel the 2's here. Again, you don't have to, but moving forward, you're going to want to do the thing that is the easiest for you, and since you have to do more math with this, okay, so this is my first derivative. Now I'm going to differentiate this again, but it's going to have a quotient rule. So since you have to do more math with this, you want this to be as nice as humanly possible. All right, so now I'm going to differentiate again. So let's go up here, and again, we'll eventually do P6, but I'm going to give myself some more room for E6. So I want to differentiate with respect to x this whole thing, dy dx equals negative x over y, knowing that this is a high function and a low function, then I have a quotient rule. So on this side, I'm going to get d squared y dx squared, because just as we talked about here, that's what happens when you differentiate dy dx with respect to x, equals, and on this side, I'm going to have low d high, right, low d high, minus high, which will be a negative x, d low, which would be dy dx, high, d low, draw the line, and then square the low, so it'd be a y squared. So I should say find d squared y dx squared in terms of x and y. So whenever you're asked to do this, and I didn't specify this, so I apologize, and it'll be the same thing up here at P6, the trick is that you're not allowed to leave this dy dx here. So what you're going to want to do is you're going to want to replace that dy dx with what dy dx was. So I've done all the differentiating that I need to do. Okay, so at this point, the calculus is done. But now I need to clean this up algebraically. So I have this negative y plus x times dy dx, which we know is a negative x over y, all over a y squared. And again, this is not wrong. Chances are that if you saw this question, you would be seeing it as multiple choice. And if you see this question, they're not going to leave the answer here. This answer is right. Like this has done everything I asked you to do. But in all likelihood, if you saw this question, you would see it as multiple choice, and they would not give this as an answer. So let's finish it out and see what they would give as an answer. So what I want to be clear about here is this is a negative y technically over 1, right? This guy's like his own little fraction. And the reason I did that is because what you're looking at here is a negative x squared over y. So I need a common denominator in my numerator. So I'm going to times y over y here, and I'm going to get that my d squared y, dx squared, is a negative y squared plus this negative x squared all over y, all over a y squared. Well, that's the same as a negative y squared, negative x squared, or minus x squared over y cubed, right? Because this was the same as flipping and multiplying by 1 over y squared. So I get this. But that is still probably not the answer you're going to see. And here's the crazy part. The answer you're likely to see to this question, and this question, although not these exact numbers, has been a real AP question, is that if you factor out that negative, you're going to realize that x squared plus y squared is a 16. So if I were giving you a multiple choice answer to this question, the multiple choice answer to this question, I guarantee you, would be that d squared y dx squared is a negative 16 over y cubed, which is super tricky, but that's absolutely what the AP would give you as a multiple choice answer. So again, I want to point out that starting right here, you had the right answer, right? At this point, all of these answers are correct. It's just that in all likelihood, if you saw this question on an AP, and I have seen a very similar question, I think it wasn't a 16, I think it was maybe a 25 or a 36, but I've seen this question on an AP, and when you do see this question on an AP, they use this trick and they want you to make it look nicer. Now, I don't know that the one I made up is going to look nicer like that because, to be perfectly honest, I randomly made that one up. So I don't know that the one I made up is going to be nicer. I did intentionally give you an E6 that looked similar to a real AP problem. So I want you to try the same thing with P6. You're going to find d squared y dx squared in terms of x and y. So I'm going to erase to get some space. And then we'll go ahead and do P6. All right, so if you don't want me to do P6 with you, then you should hit pause now because I'm going to walk through it. All right, so I'm going to come over here. When I differentiate, I get 3x squared plus 2y dy dx equals 0. When I solve, I end up getting, I'd subtract the 3x squared and I divide by 2y. So I get dy dx equals negative 3x squared over 2y, and nothing cancels. So this is my first derivative. When I differentiate again, right, I'm going to get d squared y dx squared equals low, because again, this is a quotient, right? D high is going to be a negative 6x minus high. D low is going to be a 2 dy dx. Draw the line, and then square the low would be a 4y squared, right? Because it would be 2y quantity squared. So low d high minus high d low, draw the line, square the low. So I'm going to have to replace this dy dx with this thing here, and then I should clean it up. Now, it may not clean up as nice as the one we just saw, but that's still the idea. So I'm going to get d squared y over dx squared equals, so this seems to be a negative 12xy, and I'm going to go ahead and note that it's over 1 because I see that this is going to be a fraction when I plug it in, right? This would end up being a plus 6x squared times this thing. So plus 6x squared times this, negative 3x squared over 2y, which we'll deal with in a sec, all over this 4y squared. All right, so if I clean this up, right, I would need to multiply this fraction by a 2y over 2y to get a common denominator. So I think I get negative 24xy squared minus, I think this is going to be an 18, I think it's going to be 18x to the fourth. Everybody's over a 2y, and I could actually cancel a 2 out of that top. And then this guy was actually secretly over 1, right? So I'm multiplying by 1 over 4y squared to get my denominator. So it seems to me that my d squared y dx squared, and I get that this is tedious. Remember, it's the algebra that gets to you, not the calc. And at this moment, you had the right answer, right? But in all likelihood, you would have to clean it up. So at this point, I have a negative 24xy squared minus an 18x to the fourth over an 8y cubed. So the best I think I can factor out of this is a 2, because 18 is not a multiple of 4. So the best I can do is take a 2 out, or a negative 2 if you want. If you canceled a 2 out of this, you'd get negative 12xy squared minus 9x to the fourth over a 4y cubed. And I think that's as nice as it gets. Unlike the last one that we saw, there's no trick end to this where you can magically replace the x cubed plus y squared somewhere. There isn't one. I didn't give you that option. So anyway, so that's sort of the gist, and that's how you would differentiate a second time. Let's see. Let's see if there's any tricky examples that we should do. Oh, actually, I do want to show you just an idea. Okay, so let's go back for a second to we're going to talk about when you can solve for y, but maybe shouldn't. So sometimes you can solve an expression for y, but it's not easier. Okay, so as we've seen as an example, right, I gave you one earlier where we had x squared y equals 12. Okay, so in this case, it's actually easier to solve for y. Right, because you get y equals, we figured out it was a 12x to the negative second, which is a really simple power rule, right? That's a nice, simple power rule, right? Where we just drop the power down and then lower the power by 1, okay? So that's a case where it's worth solving for y, right? But let's look at the one we just did a second ago. X squared plus y squared equals 16. Now, we saw that when we differentiated implicitly, right? When we differentiated implicitly, we got 2x plus 2y dy dx, okay, equals 0. And with a little bit of quick solving, we moved the 2x over, we divided by the 2y, and we got the dy dx was a negative x over y. And it was pretty fast, okay? So this was objectively pretty easy implicit, okay? But let's talk about how that one could have gone if I solved this for y. I could solve this for y. It is doable to solve this for y. If there is only one y in the problem, you can solve for y. It's just not always a good decision. So if there's only one y, it is doable to solve, right? But it's not always a good idea, right? It is doable to solve this. So let's solve this for y. I'd subtract the x squared over, so I'd get y squared equals 16 minus x squared, right? And then I get y equals plus or minus, technically, the square root of 16 minus x squared, right? It's technically a plus or minus. If we are assuming that we're talking about, so this is not a function, right? This is actually a circle, for the record. This is a circle of radius 4, centered at the origin. So this doesn't pass the vertical line test. So just to be clear, the reason that I had to write plus or minus is that this is the plus half. This is y equals the square root of 16 minus x squared. And then the purple thing down here, this is the minus half. This is y equals the negative square root of 16 minus x squared, okay? So the reason that I don't need a plus or minus here is that depending on what quadrant I'm in, I know both the x and y values. The problem here is that since I'm going to solve for y, what you'll find is that my dy dx only has x coordinates. Well, you'll notice that there are two spots, because this is not a function, there are two spots that have the same x coordinate and different y coordinates. So if I differentiated this, right, what's going to happen is this is actually a 16 minus x squared to the 1/2, again, with a plus or minus in front, good times. So my dy dx, or y prime, whichever notation you like better, right, is going to be, I keep that plus or minus, 1/2, this thing to the negative 1/2, times the derivative of the inside, because it's a chain rule, right? This is the outside function is the stuff to the 1/2. The inside is the 16 minus x squared, right? This is the d inside. So it's going to end up looking like this. Plus or minus a negative 2x on top of 2 times this thing, right? Which is crazy, okay? You can cancel the 2's, and what you're going to find is that you're going to get dy dx equals, I'm going to leave this plus, I'm going to put the plus or minus on the bottom with the root, because that's really why it's there. And what you're going to find is that it is exactly the same answer, actually, that we had right here, because we've already established that y is a plus or minus the square root of 16 minus x squared. But I think that this is way uglier. Like this, super friendly. This, kind of awful. So this isn't even the most egregious case of picking something where it's not worth solving for y. I could pick examples where you have to complete the square to solve for y, and you would hate it. The honest answer is that most of the time it is easier to do the problem in the form that is presented to you. So if it's not solved for y, it's probably easier to do it not solved for y. Now there are a few exceptions. This is like the one rare exception that I can think of where honestly I just didn't put the thought in to like square the y. So most of the time, if something is not solved for y, it is better that way. You should leave it alone. There are exceptions, certainly, but the exceptions are exceptions because the rule follows most functions. So you can see implicit was much easier than doing explicit differentiation here, okay? So again, it's possible to do both. It's not wrong to do either way, but I think you're going to find yourself more likely to make a mistake when you deal with this. It's the same set of answers, but a very different experience, okay? Cool. So I think let's do one more type of problem. I think we're on 7, but it's hard to know. I don't recall doing a 7, and I do think we did a 6, so we're going to go ahead and call this E7. All right. So E7, I'm going to give you a function. Let's do x cubed plus y cubed equals 4xy plus 1, okay? And I want you to find the tangent slope at 2, 1. So here you're given both the x and the y. We're going to do the same thing in P7. Let me give you another function. Let's do x plus y quantity cubed equals x cubed plus y cubed. And let's do at -1, 1. Okay, so we're going to walk through E7 together, and then you will walk through P7. All right, so same instructions. All right, so first thing I need to do, I'm only asked to find the tangent slope, right? That means I need to find dy dx and evaluate it at the point 2, 1. That's the whole answer. I need to differentiate first and then find the value of the derivative at that point. Again, I want you to notice the coded language. The AP, every test I give you, they're never going to say, do these steps. It's going to say, this is the end result, and your brain has to say what steps are required to get to that end result. And sometimes there's different sets of steps, but most of the time it's the same couple steps that we follow through. So let's differentiate first. I want you to spot that this guy over here is definitely a product. Now I'm going to put the 4 with the x. It doesn't actually matter who you put the 4 with, but he needs to stay with one of the two of them. Or you need to yank him out in front and put him in parentheses in front of your product rule, but I feel like that's just trouble. So let's differentiate. So x cubed, when I differentiate, I'm going to get 3x squared. When I differentiate the y cubed, it's going to be the derivative of the stuff cubed, which would be 3y to the second, times the derivative of the y. On the other side, I have a u. dv will be dy dx, right? Because my v was the y, right? Plus v du. Sorry, I ran out of space. V du. And then, thankfully, the 1 differentiates away to 0 because I ran out of room. Now, you have an interesting choice here. You can solve this thing for dy dx. There's nothing wrong with that, but notice that at no point was I expressly asked for dy dx. I was asked for dy dx at a point. So you can either solve this for dy dx, or, and this is probably the smarter play here, you could plug in x is 2, y is 1, and then solve. Because remember, you don't, now, if I had said what is dy dx, just the expression, you'd have to solve this first. But I didn't say that. I just want the slope at this specific point. So I think it's mathematically probably easier to do this. So I'm going to plug in that x is 2, so that's going to be a 3 times 4, which is 12, plus 3 times 1 times dy dx, so that's just a 3 dy dx, equals 4 times 2 times dy dx, so that's an 8 dy dx, plus a 4 times 1, which is a 4. I just need to move my dy dx's to either side. It doesn't really matter which. Since this is the bigger number, I'm going to move this guy this way and this guy this way. So I'm going to get 8 equals 5 dy dx. So my dy dx evaluated at 2, 1 is 8/5. Right? So again, here I cheated a little bit and I'm evaluating my, so it's not dy dx all the time, it's just dy dx evaluated at that point. And so my answer is 8/5. That's my tangent slope. All right, so you can pause me if you want. I'm going to go ahead and walk through P7. Notice in P7 that it is x plus y quantity cubed on the left-hand side. So you either have to do, not L'Hopital's, you either have to do Pascal's triangle and FOIL everything out, which is a choice, or you need to do the chain rule, which is the better choice. So pause me if you want. I'm going to go ahead and start walking through it, and I'll erase E7 when I run out of room. So this has an inside function, and an outside function is stuff cubed, right? So when I differentiate, I'm going to get 3 stuff squared times the derivative of the stuff, which is a 1 plus dy dx, because the derivative of the inside is a 1 for the x plus the dy dx. On the other side, I'm going to get 3x squared plus 3y squared dy dx, because I differentiated with respect to y. Yet again, I'm going to point out that your best bet is to plug in x and y before trying to clean up this ugly mess, right? So when I do that, right, I'm going to end up getting, so I'm going to plug in x equals -1 and y equals 1 to find dy dx evaluated at that point, -1, 1. When I do that, I'm going to get a 3 times a 0 squared times 1 plus dy dx. That's going to knock out this entire side. This whole side is going to be 0 because it's 3 times 0 times a bunch of stuff, equals a +3 plus a 3 dy dx. So now I have 0 equals 3 plus 3 dy dx. Subtract the 3 over and divide by 3, and I get negative 1 is my dy dx evaluated at negative 1, 1. So my answer is negative 1. I didn't even have to erase for extra space. Look at that. All right, so I'm pretty sure that that's our 2.5. Moving forward, we're going to talk about related rates, which is 2.6, and will be a whole lot of word problems, so get ready.